Hi guys, I'm Luca Prete from ONF. Hopefully you're not too tired from lunch and I won't let you fall asleep. I promise I'll do my best. So I hope also the title wasn't too misleading because it says deployments. Actually, this doesn't talk too much about our deployment activities, but what we learn from deployments, and hopefully how did we react to it and how we made our platform better over time, which is the platform that if you download code, you're going to consume right now. So this should be pretty obvious, at least it's obvious to me. This is how things should work and how things work for us most of the time. So when we go through a deployment activity, this is important, of course, not just for the deployment itself, but because we get a feedback from the service provider. And we try to learn as much as possible. We collect all the feedback. This feedback feeds our backlog that goes to developer, which improve the platform, and then we deploy again, right? So going through this process until core 5.0, we collected lots of good and bad feedbacks, which help us to create the new platform, core 6.0, which hopefully will be soon 7.0. And this is what my talk is about, okay? The lesson learned and how we improved. Okay, just a quick review on how core looked like back in time, a few months back. Okay, how many people use core 5.0 in this room? Okay, luckily not too many. You don't see the disaster, but you know, it was really useful for everybody. Really, we believed in it. I think it was a good lesson learned. So how core 5.0 used to work is that we were installing everything from scratch. You were coming with bare metals, and people at the time, the excuse was that they wanted to run some demos most of the times. And so they said, you know, I wanted something quick and dirty to install the entire infrastructure. So you were providing bare metals, and the idea was in one command, we're going to install everything, the operating system, the drivers, the software, Kubernetes, well, not even Kubernetes, OpenStack, and VMs on top of it, which is great, say it like that, besides the fact that there are a few caveats, which are, this requires physical machine, meaning that if you want to run on VMs, you cannot do it unless you do nested virtualization. Most of the software was even built at deploy time. So you were not consuming artifacts pre-packaged, but you were packaging and building the artifacts while you were deploying. Since we were installing the operating system, everything was OS dependent. At that time, we chose Ubuntu 16.04. It was just a choice. But of course, this wasn't the right choice for many other people. The offline installation was almost impossible. I let you just think to what nightmare could be to install such a thing that compiles stuff in China behind the Great Firewall, just to give you an example. Lots of fun. And so in short, we were installing the operating system. We were configuring it. We were installing ONOS, Volta, XOS, and all the profile all at once. It was a huge monolithic process. So also, the users had to decide which profile to install at the very beginning of the installation. So let's say you want to give it a try to install Rcord. You decided at the beginning, you say make, you wait 3 hours because the operating system needs to get installed and all the software needs to be built and deployed. You change your mind, you want to install MCore, you have to start from scratch, okay? We had quite different setup procedures for development and for deployment at the point that they diverged too much that was difficult to give support to the users in the same way. There were specialists on code in a box and specialists in the main deployment. Finally, it was difficult to replace default services provided with the platform. For example, common questions were, how do I remove mass You guys know mass, by the way? Yes? Yes. OK. So imagine it like, for who doesn't know it, imagine it like an evoluted version of a Pixie server. OK? So all the operating system was installed by mass, which is great. But again, what if I want to remove mass from the picture? Because I provisioned the infrastructure my own way, right? And this is reasonable considering that you are talking about a service provider. It was kind of difficult, even because it was managing also the DNS. There were many custom scripts masking standard tools. So imagine to have lots of make files that call other make files that call other make files. For us, it was obvious how to use this stuff. For the user, was a little bit less trivial. And there wasn't really a way to pointing them to official online documentation. Oh, sorry. OK, let's talk about the new core platform. OK, so we got all this feedback. We think about it, and we went through a huge redesign of the platform, actually simplifying lots of stuff. This was the main idea: simplify the life for us and for the users. So what's really Cord about? Cord is a control software distributed as a set of containers deployed on top of Kubernetes. OK, now, leave on the side for a second that Kubernetes is the hype right now. I can tell that compared to VMs works pretty well for me, honestly. I like it. But there are lots of advantages that come with it, right? So first of all, the control software is just running as a container. And that's what we really focus on. So we were spending, as developers, as a community, we were spending a bunch of time on the building infrastructure, on scripts that were deploying the operating system, on scripts that were configuring systems. And this wasn't really our business, right? But still, it was majority of our time was spent over there. So now users, since everything runs on top of Kubernetes, Kubernetes became our abstraction layer. This means that users can choose their own operating system, and they can choose how to configure it and which tools to configure it. Okay? Modularity. Since everything is deployed as a set of containers on using Helm charts, this comes, every building block of the system comes in a very well-defined, structure package that you deploy. So you have one command to deploy ONF, you have one command to deploy Volta, and you can decide how to, bring different parts of the system modularly together to really deploy your use case. For developers, things became also easier. They build container separately, and they release containers separately. I have a slide that talks about this a little bit better later on. So really, the new requirements now became, from the ones I showed you before, now you can run on any machine matching the minimum requirement. We have a guide online that will tell you what type of hardware you have to run. It can be either physical or virtual, because now we have containers, so there's no problem deploying also on a virtual machine. And it can run on any Kubernetes of your choice, above version 1.9. Okay. So this is a picture of how a single node deployment looks like at high level. Here I'm representing, of course, just the control plane software. Okay, so you have your bare metal, or it could be also a VM. On top of it, you have your operating system of your choice, Kubernetes. On top of it, you have a set of containers. And be aware, each one of these is not necessarily corresponding to one single container. It could be multiple containers packaged in an Helm chart. Okay, same thing for multiple nodes. So you want to deploy one node, 3 nodes, 10,000 nodes. It's really up to you, right? Again, it's not our business here. You are just spreading, installing a Kubernetes cluster on more machines. But in principle, either that you use one machine or 1,000 machine, it doesn't really change for us. This is a more complete picture. You have also the basic data plane components, okay? So you have the leaf and spine fabric. I guess you guys are all familiar with this. In SEBA, you have just one switch, the Ethernet aggregation switch. So just a subset of this fabric. And then you have the access devices on the left and the upstream on the right. So here, the entire idea of SEBA, basically, right, is that our users can go this way through the data plane and go to internet, okay? And these are just connected. This is another big news. Before, there was a distinction between an head node and different compute nodes, which was making things really, really difficult to operate. Now, all the nodes just look the same. The only thing you have to do is to connect everything to the same flat management network and install Kubernetes on top and deploy Cord on top of it. So what deploying Cord means today, what you have to do. Again, you match the minimum requirement. You install and you configure your favorite operating system. Could be CentOS, could be Ubuntu, could be really whatever. You install Kubernetes on top, and then you use Helm to modularly deploy Cord components. We made a unique repository that contains all the Helm charts. So it's easy as cloning this repository and install each Helm chart just as written in the guide. We'll see it later. I just have an example of the commands to deploy rcord SEBA. But this really becomes easy as running commands like this, okay? To give you an example. It's nothing fancy, nothing complicated. Offline deployments are possible. I added a slide because it's way more possible nowadays because we recently added a new section to the guide. This was a big requirement from service provider. And today is possible. One of the pods you see in the demo area is actually running completely offline. Now, let's go back to the use case of before. I want to try rcord. Now, I changed my mind. You know, my boss came in and said, no, now there's a new demo to do. I need to do mcord. What do? I don't have to reinstall everything from scratch. I just delete just the component, just the profile rcord. The core components remain there. I install mcord. 5 minutes. Besides the configuration that, of course, you need to apply, and the software is installed and running again. So restructuring Cord wasn't important just to deploy Cord, which, of course, is the main use case. But you may understand that changes completely the life of QA people and also of developers. Let's see how. So imagine you are of course, we do a bunch of CI/CD activities. We are connected with about 10, 20 pods around the world, depending on the time of the year. And we try to build these pods every night. We try to run tests every night. And then, you know, maybe there's a bug in master, and developer comes and send a patch, and we have to quickly test something. Imagine what the nightmare was before if you say, I have to test a change. To test that change, maybe a developer can do an hackish thing manually and change some applications. But otherwise, I have to wait 3 hours before being able to test my change. That's not good, right? So what really matters here for QA is that they can continue to run the basic system. They don't even have to reinstall the operating system and Kubernetes. The only thing they have to do is to remove the component that was changed, pull the latest component, and then reinstall it. It's easy as that. So, OK. Develop Cord. As I said, maybe I didn't underline this much, but it's very important. Cord is a collection of 50 repositories, maybe less. I don't know. I'm not sure. But imagine to have 30, 50, 70 repositories, OK, that all together need to work. So what we were doing before was tagging all the repositories at the same point in time okay, and then releasing code. Now, imagine that this is not, I think it's clear at this point in time in the conference that this is not just an effort from a single company, right? This is not just ONF. These are different communities working with different priorities and different schedules. So imagine to make 10 communities, even 5, agree that a certain day we have to release some software on all these repositories. It wasn't fun, trust me. For these reasons, we decide to start to release components separately. Each community, basically, there's some coordination, some level of coordinations that happens anyway, but what happens is that each community decides when is the right time to release a component, okay? And when we do the release process of cord, we just go in the Helm chart repository, okay? And we just tag that repository, that reference to the all the latest version of all the other repositories. So this way, we have to tag one repository for the release instead of 30 or 50. So this is not really true, but we're trying to do our best. One Docker container usually corresponds to one repository. We have our CI process. Basically, we're trying to put everything on Docker Cloud. So the idea is that as soon as a commit goes into the repository, the container is automatically built on Docker Cloud, is released. Okay? We do a release in the code base, automatically the container for that release is automatically built. And again, what we have to do is to reference to that container from the Helm charts, and that's what you will get when you download the Helm charts and you deploy code. Okay? So really, the workflow when you develop now gets down to download one or more repository, modify them, build them. You build, you tag, and you push the container. Easy as that. You want to change something, you want to try it locally, you download it, you have a local Docker registry, you tag your version of the software, you push it to your local Docker registry, you try it, and in case you push it upstream. Okay. I have to admit, it's not 100% like that, but I would say it's 99% like that. I mean, if you really look our Jenkins file or our guide, you'll see that really maybe there's one or two more commands really like this. I think it's pretty self-explanatory. You can understand what this thing does, right? You download the repository of the Helm charts, you go inside the repository, you install Volta, you install ONOS, passing a configuration and saying you are ONOS. You install XOS, and you install the profile of your choice. In this case, I just picked up the AT&T workflow as an example. Okay, easy as that. After this, well, of course, this assumes that all your servers are already provisioned, they have already an operating system, and they have already Kubernetes, which actually I can tell you that by experience for everyone is the longest process to arrive to. And it's kind of tricky, but that fortunately or unfortunately doesn't depend by us. But the good news is there are a bunch of guides out there online to help you because you are using mainstream software, right? This is the big difference. So this is what you would get, basically, with those 5 commands. Again, infrastructure in place, OS in place, Kubernetes in place. Then you run those 5 commands, and this is what you would get, okay? So RG, ONU, OLT, aggregated into the Ethernet aggregation switch, making everything going online through the upstream router or a BNG. ONU and OLT controlled by Volta, okay? Volta is controlled, of course, by ONOS. ONOS, now these two, by the way, are the same component, are controlled, both Volta and the Fabric are controlled by the same ONOS instance. Everything orchestrated by XOS, and on top, you deploy your configuration, your SEBA profile, your AT&T workflow with all your configurations. As I said, I wanted to add a couple of more slides because we have two new things. One already happened, which is this one, the offline installation. We knew that this was possible. This was one, actually, of the reasons why we migrated to the new build system. But now we also proved that this is possible, okay? If you go online on guideopencore.org, you will find a section in the installation documentation which will guide you through all the procedure. So to do an offline installation, you basically need two components in your infrastructure. You need a local Docker registry, nothing fancy. If you have worked with Docker, I'm sure you know what I'm talking about. And there are a bunch of guides online and can be done in 15 minutes, I guess, at most. If you don't want to, we provide you one. And then you need to deploy your ONF applications that usually are downloaded from online onto a normal common web server. Could be Apache, Nginx, whatever you want, okay? All the rest of the work is just going into the Helm charts and saying, instead of pointing to Docker Hub online, download the images from my local Docker registry, download the ONF application, instead of from online, download them from the local web server. Easy as that. After that, steps to deploy Cord are really the same. Nothing changes. Always Helm install, Helm delete, okay? Okay, this is a next step. This is actually a feedback I started to get from this summer from deployments. Of course, you know, till is a field trial, everything is great, right? You can start to do whatever you want. You delete, you install, and you can make things crash. But when it comes to manage a real infrastructure in production, right, you need to have the tools to support such deployment, okay? Part of this, of course, is logging and monitoring. And this is another part. I'm sure that someone has a talk or had a talk. You guys are better than me to remember when was it or where will be. So please go in the agenda. Make sure to see it. But anyway, part of that is logging and monitoring. We did a lot on that. There was a huge effort on this part. The other part is on continuous deployment, okay? What about if you have to upgrade a cluster and there are 10,000 users connected? What do you do? You start to reroute traffic around the world, and what do you do, right? Fortunately, there are other smart guys that thought to this in the cloud context, but I think this can be well applied also to what we do. I just wrote the name of a tool here, which I think is very valuable, and we should all look at that. It's called Spinnaker. Without making it too long, hopefully, and I'll try to be clear as much as possible. It's a quite complex tool, but essentially what it does is it allows you to upgrade live a set of containers, geographically distributed, running on different cloud platforms. How it does it? It basically instantiates a load balancer in front of your containers, and it starts to slowly migrate the user traffic to the new versions of the containers. You can run tests against these new containers. If something goes wrong, automatically rolls back the traffic. When the migration is over, it makes the new containers disappear, okay? This is what it does. Nothing fancy, but it's really important. And when it comes to detail, it's quite tricky to do it properly. So there's a principle to arrive to this so-called CD process properly. One of the basic principles is that your infrastructure is immutable, okay? This means basically, for example, that your containers need to be stateless, okay? Right now, our containers are not stateless, okay? Because when we deploy with Helm chart something, I give you an example. An example of something we already solved, by the way. Volta. Volta uses etcd to store its data. Okay, when we install Volta and when we remove Volta, we were removing and installing with it also etcd. Okay, so how do you install the new version of Volta maintaining the data store? You have to separate the two installations. Okay? So the stateless part goes on one side, and that's the part that you can upgrade very carefully, keeping track of the APIs that change anyway. And on the other side, you have the store, okay, which remains there, and hopefully you have other ways to upgrade more carefully. Okay. To give you an idea, I just want to leave you with this data. There are, I was at the Spinnaker conference recently, and I heard lots of great things. I was really impressed. Nothing wrong with you guys that come from the, well, with us that come from the telco environment, but I'm really impressed when I go and I hear Netflix that tells me, you know, we do 4,000 upgrades a day to our container infrastructure. Yeah, just to give you an idea to what's really possible with these tools. I don't think it's impossible. I just think we need to work on it and work a little bit on the mentality to get there. But yeah, this is definitely something that is on our path, on our way. Okay. This was all. Hopefully it gave you a good overview of what we've done so far in the last year. Thank you, everyone.